Almost every business on the planet uses a database. But for many applications, conventional databases have a blind spot. They only help you look backward at what already happened in the rearview mirror. That works, but only when conditions stay the same. When conditions are volatile, you need to query the future, not only the past. You can do this with an unconventional technology, stream query processors. Here's how they work. First, you connect streaming data to a streaming platform. Streaming data comes from IoT sensor readings, financial transactions, Kafka events, database log updates, Twitter tweets, just to name a few. But these data sources aren't easily queryable because they're in motion, and that's where the stream query processor comes in. For example, imagine we run a drilling operation for an oil company, and you want to be alerted any time a well is likely to experience danger in the next few minutes or hours, given historical patterns. A stream processor takes a question like, select all oil wells showing signs of failure for greater than 5 minutes, and creates live tables that match the query. There are two unconventional parts of this query. First, signs of failure can be anything a domain expert might specify that compares historical indications of failure to real-time conditions. Temperature readings that are too high, voltage readings too low. The other is the temporal nature of streaming queries. Real-time systems are notoriously spiky. You get a lot of inaccurate readings or occasional outliers. The trick is to smooth them out so the system isn't effectively crying wolf. Now the query processor goes to work. A dashboard or client application gets an immediate snapshot. Here we see a table of wells currently at risk. But continuous queries stick like glue. It holds the query in memory. As IoT sensor readings change, queries are reevaluated constantly. The live table's updated as the query is rematched over and over and over again. With conditional formatting and BI tools, you can make them pop on a dashboard or trigger actions and alerts. As new wells match the query, a row is added to the table. Here, well G is beginning to show signs of danger. It's added. Rows are deleted from the live table as conditions improve. Now, only well C and G are of concern. Now, these live tables act like normal database tables in some ways. You can sort, aggregate, filter in some values. And you can drill down on them, right? But you can also set alerts that trigger actions. Here's an example used by an insurance company that continuously tracks a storm as it approaches Florida. We analyze a streaming weather feed forecast in real time. Streaming queries fire with each change in the forecast to predict where the damage will be worst. This helps analysts decide where to deploy staff, fix supply chain issues, or simply warn their customers. And you can see the big picture of projected financial damage and take action right from the dashboard. These systems help teams sense and respond to changing conditions like the bear in the stream, searching for salmon over and over and over again. Now, not every enterprise application needs to query the future, but for some environments where conditions change frequently, it can be a game changer. For example, stream query processors were invented on Wall Street for high-frequency trading and risk management, and it's a must for industrial IoT applications like predictive maintenance and drilling. Or in Formula One, since every race, track, and weekend has volatile and changing conditions, and Formula One cars have hundreds of embedded sensors that can be queried to anticipate the best race day strategies. High-tech robotic manufacturing systems query IoT sensor streams to ensure quality output and efficient operation. And in retail, knowing what to offer your customer next based on history requires foresight. So flip your thinking upside down about data. Don't only look in the rearview mirror. Query the future to become more proactive in today's volatile and unpredictable business world. To learn more, check out the resources in the comments below or visit www.technosapien.com.